Hello, my name is Somiklal Bhattacharya, and we are here today for the internship at Sparks Foundation. And this is my first task, which is prediction using supervised ML. We are given to predict the percentage of a student based on the number of study hours, and we have to use the linear regression. I will be using R, and you can find the dataset at this site, which is if I go to this site. Which is this data. Now we can go to R and we can load the data right this here by using a read.csv and directly putting the URL, and then we can run this, and our data is uh, here. I can see 25 observations of two variables. You can first do some exploratory data analysis like checking the head of the data, which is given by this head of data, and then we can check the summary of the data, which gives this values like which is the minimum and of hours and scores. Then we can proceed to checking the structure of data. There are 25 observations, and hours is of type numerical and scores variable is of type integers. We can then go and check for is there any like null values in our data, because if there are null values then we have to deal with that. So we type a command called any is.na, and then we run this command, which gives false, that there is no false there is no actually zero null data in our total data set. So then we give this values of we assign the scores and hours to the variables x and y, and we plot them by using a plot, or you can if you are familiar with the um, packages ggplot2, you can also use that to plot it, but I'm doing this because uh, to be able to do it at the simplest level possible. And as we can see that there is correlation between these two data. Then we are trying to build a model, which is given by this model LM. LM stands for linear model, and we are using y as a dependent variable on x. We're trying to predict y actually, which is the score uh, based on the number of hours the student studied. Then we can see a quick summary of the model, which is given by this function, where it just says the formula and then minimum, median, first quantile, third quantile, maximum, and coefficients like the um, standard estimates and the coefficients, t-value, probability which is less than 0.05, that means it's significant. So the t-value is quite high as 21. Then we can check for the R square, which is at 95%, which is quite high, and if statistic is also very large, 465.8. So our model is pretty good at this point, so we can continue with the model, and then we can actually have a plot of this model, which gives us these various graphs like residuals versus fitted, normal QQ, scale location, residual versus leverage. For this, to understand all these graphs, you can have a glance at Wikipedia and search using these models names. Then we can actually come to the prediction part, where we use a variable called score prediction, where we predict the model using our data, and then we print this so we can actually see how our prediction looks. So this is our predicted model. These are the values actually using our predicted model. Then there was a question where we can actually predict score if the student studies for 9.2 hours per day. And we can use a variable called object where we run the data frame where x is equal to 9.25, and then we can use that to predict where x is equal to the number of hours studied, and then we can run this model using the object, and then we can print the result, which gives that if a student studies for 9.25 hours, his or her projected score is predicted score is 92.90985. Thank you.